Good day. My name is Christine Miller. I'm a student at the California Intercontinental University. Today, I will be presenting on visualizing hypothesis testing. Let's first look at we will be defining a hypothesis test. We will use visualizations to explain the hypothesis test. We'll look at takeaways from the presentation, and then we'll have questions. Why do we need to do hypothesis tests? Hypothesis tests are used by researchers to test an assumption about a given population. To be able to make this assessment, a null and alternative hypothesis must first be developed. The null hypothesis is the statement which reflects an outcome where there is no relation between the variables that are presented, while the alternate hypothesis states that there is a relationship between the variables. It must always be remembered that the assumption is that the null hypothesis is true. We will now be using visualizations. The first one, the research question for it is, on average, are the widgets from Acme Widget Company defect-free? The hypotheses for these are, the widgets from Acme Widget Company are defect-free, that is the null hypothesis, while the alternative is, the widgets from Acme Widget Company are not defect-free. The bell-shaped curve, as displayed in the graph on the previous slide, is used to represent the results of research and plot the data points. It is also used as the mean of the research data is represented by the highest point on a normally distributed curve. It reflects the standard deviation of the sample around the mean. In this test, the null hypothesis is at 0. This means that the likelihood of the sample being far from the null is relatively low. With the sample size of 100, the degree of freedom would be calculated using the formula. The degree of freedom is equal to n minus 1, which means that the degree of freedom is 99. The conclusion for this visualization is that, assuming that the t-values of t plus 2 and minus 2 are being used, and a degree of freedom of 99, the p-value for this two-tailed test is 0.04824. Therefore, the null hypothesis cannot be rejected, as it is not significantly below the accepted level of significance of 0.05. In the second visualization, we'll be comparing two groups. The research question for this is, does the average Major League team have more home run hitters than its corresponding minor league team? The null hypothesis for this is, there is no difference between the number of home run hitters on a Major League team and a minor league team. The alternative is, there is a difference between the number of home run hitters on a Major League team and a minor league team. What can we determine from the curves about the hypothesis? The mean for the Major League is higher than that of the minor league. Therefore, if a sample test results in the null being rejected, then the graph could be used to demonstrate that the mean and therefore the score is higher for the Major League. In this scenario, the approximate mean for the Major League is equal to 0.37 and the approximate mean for the minor league was 0.29. Our conclusion for this visualization is that as a result of this, the null could be rejected, as it has been determined that there is a variance between the major and minor league. Moving on to the third, which is an efficiency comparison. The research question is, the efficiency curves on the red and blue teams were recorded. Do the teams have equal mean efficiencies? The null hypothesis would be the mean efficiency of the red team is equal to that of the blue team, while the alternative hypothesis is the mean efficiency of the red team is not equal to that of the blue team. We are able to determine the mean from the curves. The approximate mean of the blue curve is 50, while the approximate mean of the red curve is 30. The steepness of the red curve signifies that it has a lower standard deviation than the blue curve. What does that indicate? 1. The lower the standard deviation, the lower the difference around the mean. 2. The lower the standard deviation, the lower the risk. 3. The higher the standard deviation, the higher the difference around the mean. And 4. The higher the standard deviation, the higher the risk. We can conclude that for this visualization, that while the mean is higher on the blue curve and has a high standard deviation, which means there is a wider dispersion of the observations around the mean and is a less accurate predictor of population variables. However, the larger the sample size, as with the red curve, the greater the predictor the sample may be to the population, and hence a lower standard deviation. For the fourth visualization, we're doing a correlation test. A German study was done on how larger industrial use vans utilize gasoline. They plotted the miles per gallon versus the weight. The important question that needs to be asked: what were the study's null and alternative hypotheses? The null hypothesis would be the gas usage of industrial use vans are not affected by the weight of the van. The alternative would be the weight of the industrial use van affects the. Scatter graphs gives another pictorial view of research data. What does it tell us, and in particular in relation to that graph? Each dot represents one data point. The line gives the best fit line for the data set. Also, there is a correlation between the weight of the vehicle and the miles per gallon, as the dots are closely grouped around the line of best fit. And lastly, the p-value as indicated on the graph is less than 0.0001, which means that there is a strong relationship between the two variables. In concluding on this final visualization, based on how scattered the data points are around the best fit line, the variables are correlated. Also, given a p-value of 0.0001, the results are indicating the null hypothesis should be rejected. The weight of a vehicle does in fact have an impact on the gas mileage of the vehicle. The important takeaways we have, firstly, in relation to creating hypothesis tests, is that a null and alternative hypothesis must be developed to test a research question. And also that the assumption is that the null hypothesis is always true. And then secondly, in terms of using visualizations, we find that the mean is the highest point on a bell curve, and also that the graphical representations of research data can assist in determining if the null should be rejected. Thank you for watching and listening to my presentation. And if you have any questions, please feel free to ask.